45.
Did you do 4? Did 4?
Right, let's do these. If the refractive index of water is 1.33, then how fast will a radio wave travel? Can we see? Yeah. So N equals C over V. V equals... oh, sorry, that's the wrong way, isn't it? N equals C over V. No, that's it. I want V equals C over N, which is 3 times 10 to the 8 over 1 point, what did I say it was for N?
1.33.
Was it? Yeah. Which is 2.26 times 10 to the 8 meters per second. Right, number 2.
The same.
It's 1.33 and it enters at 45. What does angle is it afterwards? So here we have comes in at 45 and then it leaves at or. This is 1 and this is 1.33. So sine 45 over sine or equals 1.33 over 1. Did you get that?
Yeah.
Yes.
So
52.1.
correct. Or equals 32.1 degrees. Yeah? Okay, the next one.
No, wait.
When light enters a diamond, it is difficult for the light to escape because the refractive index is so large. What is the critical angle? So what did you get for the critical angle here? 24 degrees. So what's happening here in your diamond, look guys, can you look? I'll explain. So what happens is the light comes into the diamond and because this angle is so small, it's very easy for the angle to be bigger than this, the theta 1. Let me just draw it in here. Here's theta 1. Can you see that? So, because this angle is so small, it is likely the theta 1 will be bigger than this. Yeah? So that means if it's past the critical angle, will the light exit or re-enter? He'll come back in. Because remember, if it was equal to 24, it goes on the boundary. But if it's greater than 24, it's internal. So what's happening here is because the critical angle is so small, it means the light is more likely to re-enter until it becomes less than 24 degrees, and then it can exit. So this is why the diamond sparkles, because the light has difficulty escaping. It bounces around a few times before it can exit. Also, the diamond is cut so that it makes it more difficult for the angle to be less than 24. We want the angles to be greater than 24 to keep the light in as long as possible. So this is why the whole diamond appears to be fully lit, i.e. it sparkles.
So it's basically because of the shape.
Because of the shape and the high value of n makes a small critical angle. The smaller the critical angle, the more difficult for the light to escape. For example, consider this extreme possibility. If the critical angle equals 1 degrees, then nearly always the light theta 1, it'll always be bigger than 0, true? And it'll mostly be bigger than 1. So if you had some material with the critical angle equal to 1, it means it's very difficult for the light to escape until it can make an angle smaller than 1, and then it can escape. So this is why the diamond sparkles, because this is so big, which makes this so small. That's the reason why. Yeah? Does that make sense? Yeah? Okay, continue. Red light is shone through glass at right angles. The glass has refractive index of 1.5. At what angle does it leave? Did anyone get this?
Yeah.
What? Number 4. What answer did you get?
The A.
Yeah.
Yeah. G1.5.
No.
What?
No.
No.
No. It hits the glass at right angles. So this means that theta 1 is 90. Yeah. So did you do sine theta 1 over sine theta 2 equals n2 over n1?
Yeah.
Ah, okay. No, my point is, this is a trick question. Because it hits it at 90, it continues straight. So the answer is 90. It was a trick. It was a trick. Okay, now number 5. And how are we doing? We got time to finish these? Oh, yeah, we do. An equilateral prism is placed on the table and green light is shone through it parallel to the table. The index is 1.45. At what angle does the light make with the table when it exits? Right, so this one's a bit hard now, and unfortunately it was an exam question, but if I draw it carefully, I think you'll be okay. So this is an equilateral triangle. So that means I know this angle is 60, this one here is 60, and this one here is 60. And the green light comes in here, hits it here, and then it refracts. So I should draw the normal here. I need this angle first. And the angle will get smaller, so I'll put it like here, for example. Right, so do we know this angle? This is the first question. Well, we could know it. For example, if this is 60, what's this angle? 60. And if all of this is 90, what's this angle? 30. Because this makes a 90. Because it's the normal. It's perpendicular. So you can say sine 30 over sine or equals n2 over n1. So here, 20.6 degrees. So that's 20.6 here. Now the light comes along and it hits the prism here, and again there's a normal, and again it leaves. This is it here. Yes. Will it go up? It'll go down because it'll be a bigger angle. Oh. So this angle here is the one we want. And again, can we know this angle? Now this is where it gets a bit hard. If we know this angle, then we can get this angle, then we're finished. So what is this angle here? My goodness, okay.
30?
No. We know this one here is 20.6.
So.
Yeah, if I draw this one... No.
Maybe that
Why
is
not?
also 20.6.
Maybe. We don't know.
No,
This one?
yeah.
Why the question doesn't...
You are exactly right, Fuan. Congratulations. 20.6. And the reason is because this line is parallel to this line. So again, it's one of these things in maths. Yeah, it's very good. This angle is the same as this angle when the lines are parallel. So then that means this angle here is 90 minus that 69.4 degrees, or 38 degrees. So now we have sine 69.4 over sine or equals n2 over n1. It's the opposite because it's going the other way. So this angle here is 40.2. And I think my question was, at what angle does the light make with the table? With the table. So I wanted this angle. So if this is 40.62, let's see, we can know this angle. I know this angle here. Let's see, if that's 60, this is 90, so what's this angle here? This is 90 and this is 60, this is 30, very good. If this is 40.2, can I know all of this? Yeah, 180 minus it. That's 139.8. So if I know these two, can I know this one? Yeah, it's 180 minus those two.
Yeah, okay.
Which is 10.2 degrees is the final answer then. It's a difficult one, but this was a section B question in the physics exam a couple of years ago.
One of the ones you don't choose.
Yeah, but if you're good with angles, you know, it would be a good question for you. No? Okay, so you definitely want to write this one down, I think. Yes. You might even want to watch the video again. But, yeah.
That's nice.
Well, will we just go to the next question then? You can grab it later.
Yeah.
Okay.
Using sub sine r by 21.
Huh? For which one?
The second one. You find
I did.
20 points.
Here. Oh, but the angle wasn't 20. It's this one with the normal. You measure the angle with the normal always. So I don't use the 20.6, I use the 69.4. Is that what you mean? Yeah. Can I go to the next one?
Yeah.
Yep. Right, so next one now.
Last one.
Yeah, so a man is standing and his height is, what did I say?
1.5.
1.5.
It's very short.
And the lake is 3 meters deep. And here's the water here. And he sees a fish 2 meters in front of him
2 meters.
and 2 meters up down. So he sees the fish here a distance of 2 meters out and 2 meters down. But the fish isn't really there, and you might know this. The fish is actually really here. And what's happening is when the light from the fish comes out, well, hang on, let me draw this again.
It seems that the fish is near.
Nearer to him than it is, yeah. So the light refracts, of course. So he thinks he's seeing the fish here. In fact, the fish is further down. You might have noticed this when you're looking in pools. The thing looks higher than what it is.
Yeah.
So, what is my question asking you then?
The hypothesis.
Yeah, how far away could the fish be? Yeah, so actually I drew this fish underneath here. I don't know if I should have done it that way. Actually, I think I've made this question the wrong way. No, hold on.
Could be the wrong way. Could be like swap the fishes or something, right? What?
Hang on, let me just think if I want to change this or not. Maybe I shouldn't tell you how deep the water is. Maybe I should ask you to work that out.
Okay, 3.
It might not be 3. We'll see. I don't know if this is going to be too difficult. Sure, what's the worst that could happen? Let's see. Right, so what angles could we know? So I'm going to change this question, make it a little harder. Yes, that's right. You heard me correctly.
It's harder.
It's hard enough. Right. So, I now made it too hard.
Yeah.
Now you know.
And you know what?
Was this
Pretend
an
the
exam
feedback.
question?
This was an exam question. I'm going to bring up the exam question and show you. No, you don't. You love it.
Nobody loves that.
Love it deep down. Look inside you. Yeah, it was an exam question, but maybe I made it a little bit too difficult.
Make it easy.
No, make it easier.
Say the part number 5 also.
It's not quite this one. It was in section B.
You can take it on.
Or more.
If you want.
Yeah.
Well,
That's the
hold on there.
We have
Hold on there, please. I want to find it to show you it. It is here. Don't you worry. Don't worry, you'll get your cake now. Just relax. Relax, you're distracting me. I'll just check one more year, and if I can't find it, we'll just forget about it.
I think I saw the word fish.
Yeah, there was another question with a fish in it, but that wasn't the one I was thinking about. There it is.
Ah.
What is free?
and they told us that
They told you this distance, yeah, okay. And this angle,
So they told us the real distance?
the real distance, and they wanted the apparent distance, yeah, okay. So,
yes,
is that what you meant?
Yes.
Okay, so what I'll do is I'll change this question a little bit. I'll tell you this distance like I did in the question.
Free.
Um,
five.
And this is x.
That's what we want.
And this is what we want. And
The
they didn't tell you this and they didn't tell you this, but instead they gave you an angle. So we'll make this angle easy. We'll just say it's 45 degrees or something. So he sees the fish at 45 degrees.
Yeah.
And the fish we know is 3 meters below the water, but we want to know where does he see it at. So if the light didn't bend, it would just go straight to the fish, and this would be 3 meters. But because the light bends, the distance he sees it will be smaller than the 3 meters. You know what? Maybe we'll just do, or maybe we'll just keep the numbers the same as this one. 30 and 1.2, yeah?
Yeah.
Yeah, okay, so we'll keep it the same then. This is 30. Is it 30 looking down? 30 the other way. They said this one was 30, so this one here should be 60 then. They said this one here was 30. And this one was 1.2, and we want the x here. I don't think they gave us anything else, did they?
But how did you know?
How would you know?
30 plus
It's the right.
20 plus
Oh,
5.
sorry, this one's 30. I'm screwing this up. This one's 30. Now we're back to 30. This is 30. Okay, so that is 30 and that is 1.2. And we want to find the x here. And I don't think there's any other info that will help you except for the 1.33 for the water. Now I'll give you a little bit of a help to get you started here. So here, this is the normal. So what angle does this make with the normal? With the normal? 60. So do you know the angle here? Yes. Do you know the N1? What is it? If it's air, it's 1. And do you know the N2? 1.33. So do we know this angle? Can we know this angle? No, I mean we could work it out using the formula. Yeah, so we can.
This was D45.
We'll use the formula. We can get this. Yeah. Now, do we know this distance? We do. We know that this distance here, and we know this angle. So could we know this distance?
Yeah.
Yeah, we can know this one. So yeah, using cos. So we can know this, and this, and can we know this? Yes, we can. So you see what I'm saying? You're building up, getting closer and closer to working out the height here.
Okay, so after I get the height, what means what I do?
Well, you see,
But what?
he thinks the fish is straight across from his eyes. So if this angle here is 30, then you can know that this angle here is 30. Yeah? Now, if you know this distance here, and you know this distance here, and you know the angles, what you're trying to do is you're trying to work out this length here. So if you could get this length, you would be finished. Because you know this angle, you know this angle. If you know this length, then you can know this length. So you do know this length though, because we just said it's going to be the same as this one here. So the key is recognizing that if you have this length from here, and you know this angle, then I think you have enough information to work out this side. So my advice when you do this at home is first finish this triangle by getting the angles and the sides. You actually already know this side is 1.2. Once this triangle is complete, then you can compare it with this one here to get the one you really want, which is this side here. Yeah? It's a hard one, but I have to do it because it was a Section A question.
Section A.
You had no choice that year.
What?
Now, in fairness though, this is the most difficult Section A Snell's Law question I've seen. The only one that will be nearly, the only one that's more difficult than this is the previous question with the triangle, but at least that was a Section B question. So you didn't have to do it.
Which year was this?
This one was a long time ago, 2010. This was written by the previous physics teacher in Manchester. So the current one, he doesn't quite write the questions the same way as this one. So I think, for example, the triangle one I gave you, that was written by the new physics exam writer. And I feel like, you know, that was hard as well, but at least he put it into Section B. So I noticed that with the current exam writer, he usually makes one question really hard in the exam. So it's important that you don't choose that one. Sometimes the question is the wave question he makes hard, but I think usually he likes to make the mechanics hard. So he kind of switches in between two modes. One year he might give a very easy mechanics questions about projectiles, and then another year he'll give a very hard question about projectiles. So sometimes you can get good mechanics ones and sometimes bad. But we'll talk all about this when we're reviewing the papers. But there's always at least 3 questions in it you can do. And I think he always does a very nice electricity question, you know, with Kirchhoff or a graph or something. So for me, I always recommend the students for his exam to do electricity, to do materials, which we haven't done yet, and usually to do waves. Waves is good, but if waves wasn't good, then you can do the mechanics one instead, you know. But we'll talk all about exam strategies nearer to the end of the semester too. Right, so we'll leave that one question for our homework then.